We'll now look at the false position method. So the false position method, just like the bisection method, is also a bracket method. So bisection method, one of the limitations of it is that it can take very long iterations to get convergence, meaning that you need to repeat the steps many times until this condition here is satisfied. So one way to speed up the convergence is to use the false position method. Being a bracket method, the first step of your false position method is again to make an initial guess of what XU and XL are. And just as the bisection method, the XL and XU that you choose here must be such that the root or the position of the root is located in the middle of XL and XU. So that is the first step. In the second step of your false position method, we are going to draw a straight line that connects the 2 points XL and XU. So when we draw a straight line, what we want to do next is we want to find the point where this line actually crosses the x-axis. Alright, so how do we find the point where it crosses the x-axis? If we know XL and we know XU, by right we should know what is FXU, sorry, XL and FXU. Alright, so knowing XL and XU, you know the corresponding values of F. If you know these 4 points or 4 values, it is easy to derive the equation for this green line over here. So that equation can be written as x minus xl, xu minus xl is equals to fx minus f at xl divided by f at xu minus f at xl. Okay, so this is the equation for this green straight line. In order for us to find this particular point, we know that the value of f at this point must be equals to 0. Okay, so in other words, to find this point here, we know that this is equals to 0. So if we rearrange this equation, we get x to be given by xu minus xl, or let me rewrite it again. I'll rewrite this as x is equals to xl minus fx times xu minus xl divided by f at xu minus f at xl. And what is this point? This point is going to be the approximate position of our root. So I'm going to call this xr, and this would be the equation that we use to find the approximated position of the root. So we can see with false position method, we find the estimate position of the root based on this equation, which is essentially the equation for this straight line. With the bisection method, we use the midpoint between XL and XU. So the step following here would be similar to the bisection method. To find out whether this value here is close enough to the exact root, we find out if the magnitude of f evaluated at that point xr is less than epsilon. If it is, then xr is your root. If it is not, then you have to find out whether the xr is located to the left hand side or to the right hand side of the root. So you do that by multiplying the values of f at xr and xl. If this is positive, xl is substituted with xr. If not, xu is shifted to xr, and you repeat the step. So you can see this the steps to run false position method is similar to the bisection method. The only difference is how you calculate the estimated position of your root. And because we are using a straight line to connect the two brackets here, the convergence for the false position method is usually faster than the bisection method. So now I have outlined the two steps or the two methods for bracket methods, i.e. the bisection and false position method. You should know that bracket methods have their disadvantages, and these disadvantages you can refer to them in your lecture notes. I won't go through all these definition type contents in this recorded lecture, so please go through the printed notes or the PowerPoint slides to go through the disadvantages or the limitations of the bracket method. This limitation of bracket method can be overcome by using the open methods, which I will go through in the next part of this lecture.